Hey guys, today we'll be solving the problem part 12 of problem 2.2 from the book Mechanics of Materials 6th edition by James M. Gear. Here the question states that the horizontal rigid beam ABCD as seen in the figure is supported by vertical bars BE and CF and is loaded by vertical forces P1 which is equals to 400 kN and P2 which is equal to 360 kN acting at points A and D. Bars BE and CF as we can see in the figure are made of steel where we take E as 200 gigapascal, and we can see that the cross-sectional area of BE and CF are given as 11,100 mm square and 9,280 mm square respectively. Now the question has asked us to determine the vertical displacements delta A and delta D of points A and D respectively. Now let's look into the solution. Here we have been given all the known values. Firstly, to find out the force at CF, we'll have to take the summation of moments at B, which is equal to 0, and we take clockwise as positive and anti-clockwise negative. So we can see 400 is multiplied by 1.5 since the distance between A and B can be seen is 1.5, and similarly FCF, which is unknown, is multiplied with 1.5 since similarly the distance between B and C is 1.5, and again here 360 is multiplied with 3.6 because the distance between D and B is 1.5 meter plus 2.1, which comes out to be 3.6, and here the symbol has been taken as negative because this is in anti-clockwise. And finally we get the value of FCF as 464 kilonewton. Similarly, by taking the summation of moment at C as 0, we get the value of FBE, which is equal to 296 kilonewton. Now here, by using the elongation formula, we can find the value of delta BE, which comes out to be 0.400 mm. Similarly, we can find out the value of delta CF by using the elongation formula, and the value comes out to be 0.600 mm. Finally, in order to find out delta A and delta D, for delta A we can see the expression delta A is equal to 2 delta BE minus delta CF, and since we know the value of delta BE and delta CF, we can substitute the values, and finally we get the value of delta A as 0.200 mm downwards. And similarly for delta D, we get the equation delta D is equal to 12 by 5 delta CF minus 7 by 5 delta BE. Here we substitute the value of delta CF and delta BE which are known, and the value of delta D comes out to be 0.880 mm downwards. And from all the known values of delta BE, delta CF, delta A and delta D, we can get the displacement diagram as we again see here. Thank you very much.